So we're going to do the FRQs together, and some of them we won't like finish it off. We'll just set it up and you won't head off to your calculator. So we'll try to go through those fairly fast, but there's some really good meat in those. So distance learners, don't fast forward through the video. Really watch those FRQs. It's actually got one of them's really difficult. The other two are pretty straightforward. Your assignment for today is a journey through calculus. It's number 38 in your binder. You really ought not have to do A through Z. If that's the case, it would make me worried. All right, so you're going to look through it. You're going to read question A and say, would I know how to do that? 100%. Just put a star by it and move on to B. Would I know how to do that? 100%. Put a star by it, move on to C. If you're like, I'm not quite sure about this one, do it. Does that make sense? You should be starring more than you're doing at this point, is my hope. So although it looks like a long assignment, unless you're actually going to do all of it, which some of you might want to at this point, because, you know, it's for college credit. So if you're like, I'm pretty sure I know how to do that one. If you have time, make sure you do. But if you're like, I know I'm going to get past this test and I have a whole bunch of other stuff to do, then just really focus on those that you're not 100% sure about. When you're done, you're going to pop onto the key. Okay, and it's not a video key, it's a paper key. And you're going to go look through all of those that you did, all right? See how you did, fix the ones you skipped or missed or whatever, and we're kind of hoping for 60% or better right now, all right? So if you're like, well, I did 25% of those, and of those I had 10% wrong, that's actually really good. So do it that way. Same with tomorrow. In class, if we had class on Friday, we'd take care of set 7. It's the video, the 10 multiple choice of 1 FRQ, but I don't think we need all of that because it's a really recent chapter. So if you want to meet me at 1:15, we can just peruse it, and all you need to be held accountable is for those things we actually stop and do. But so it'll be a lot shorter than if you don't go to the meet, because in that case I have to have you do all of it because I don't know, you're not there to answer my questions, if that makes sense. So if you can meet me during 6th hour at 1:15, it'll be less time than if you choose to do it on your own, but I really don't care. All right? Also, the extra credit for tomorrow. Oh, and again, I got to discuss tomorrow as well, because tomorrow's is kind of the same thing as today. There's a sheet, 41 and 42, that's got you got to know on it. There's 4 FRQ stems. All right? And again, only do the parts you don't know. If you know all of it, then right, I know all of this, and don't do any of it. That's kind of, any questions on that? I just want you to do what you need to do, and I'm fine with it. The extra credit for tomorrow, though. Every day has an extra credit. I obviously can't meet after school, but I gotta scroll. I'm gonna go over here, particularly for the distance learners, because I just want to make sure they've got their poop in a group here. By the way, distance learners, make sure you contact me if you have any questions. You've been doing your stuff, but I just haven't heard from you guys much. So a meet tomorrow if you want it to be shorter, but if you're like, I'm just going to do it on Sunday, fine. The other thing, the extra credit tomorrow. We've been focusing a lot on FRQs this week. We're going to go back, and there's a Google form for doing a multiple choice practice test. If you meet me at noon to do it, I'm going to have you do it, and then we'll go over like the 3 most missed, and we're going to estimate your score. So you'll be like, I'll say, well, if you got, 21 to 30, you're at a 5. If you got this to this. So if you want to do it that way, join for the meet if you actually want to take it like a test. All right. If you're like, I just want to see the questions on there, then it's a link to the practice test is right here, and you can just do it on your own. But it's extra credit. So it seems like there's a lot on Friday, but if you meet me and know most of this stuff, it's really not a whole lot you have to do. All right. So like if your parents were to look at that, they go, holy crap, that's going to take you all day. It shouldn't. Right? Unless if you need it, then you should take Calc 1 over again anyway. All right, so what are we going to do today? We're going to hop on to the FRQs. We're going to do number 5 first. We're going to do 4 last because 4 is the one that's really tricky. So we need to get our brains warmed up. So we're going to discuss, maybe not do all of number 5. 5 is pretty straightforward. It's just got some old stuff. So we've got a piecewise function, and we're asked if we're continuous at 1. So there's 3 things you have to remember that you need to show for continuity. Give me one of them. Go ahead, anyone in here. For a function to be continuous, what must happen? F of 1 must exist. So you're going to go F of 1 equals. F of 1 puts you in the top piece because that's where there's the equal bar. It equals 1 plus 3 equals 4. Done. You could say therefore F of 4 is defined, or you could say exists, but whatever. I do have a closed dot there. Awesome. What else do you have to have happen? Left and the right limits equal the same. So we're going to go limit x approaches 2 from the left of f of x. Don't forget your subject. We just did it. It's 4. So not very, this is pretty basic, right? When I come in, limit x approaches 2 from the right of the function. Sorry, 1. Why am I doing it at 2? 1. When I come in from the right, that's going to put me on the bottom piece where I'm bigger than 1. And that'll be 1 cubed, which is 1, plus e to the 0, which is 1, which equals 2. You'll stop and answer this question. Because what happens is I came in from the right and I was at 4, but I came in from the left and I was at 2. So you're right, Bryce, that was it. Usually that's a yes, but this was a no, right? So what do we write? F is not continuous. Are we good? That was, hopefully that you were like, that's easy. Second one, really straightforward as well. We're to find the derivative at -1. Top piece or bottom piece? Top. Go ahead, Max, give me the, I don't want to scroll all the time. Can you give me the top derivative? And if you're wrong, well, I'll just go boo.
2x plus 3.
There's no boos, so I'm going to assume that he's good. F prime of -1 would just equal 1. If that made you sweat, you're making me sweat. That was not hard. F prime of 2 will be in the bottom piece, but I don't want to go look at it. So F prime of x on the bottom piece, how about, Clocker, can you tell me the derivative of the bottom part of the piecewise function?
3x squared plus 2e to the 2x minus 2.
Perfect. She remembered to multiply by the derivative of u. And then you go put a 2 in there. 3 times 2 squared. And this is easy, so be careful you don't get sloppy when you're on an easy one. So just kind of methodically, we're going to put a 2 in there. We don't get e to the 0, we get e squared. So this would be plus 2e squared. There. Done. That should not have made you sweat. If that made you sweat, that would make me worried. Number 4 should make you sweat. It says explain why f prime of 1 does not exist. Well, Bryce kind of already, well, no. F prime of 1 doesn't exist, not f of 1. So here we go. F prime, right, of x equals, what was the first one you said, 2x plus 3? Is that right? 2x plus 3, when x is, was it less than or equal to 1? Is that right? I'm going to do the derivative of the top piece. Okay, so f prime of 1 would equal what? What's f prime of 1 going to equal? 5. Okay, that's when I'm coming in from the right. When I do the derivative from the left, what'd you tell me the derivative was again?
3x plus
2x minus 2. And you would probably have a little more work here, but this is an easy question. What will I put in now? A 1. It says explain why it doesn't exist, though. I'm going to get a 5 again. That's weird. It does exist, because I'm getting, oh! It wasn't continuous. Oh boy, did I just goof up. Is that, sorry about that. Part A, this is easy. I was like, wait a minute, they've got the derivatives are matching. They are, but f prime of 1 is not, or f prime of x is not continuous at x equals 1. Remember, you have to be continuous to be differentiable. All right, sorry about that. That was me being sloppy because this is an easy question, which I just told you not to do. But I want to get through this one. All right, now what am I supposed to do? I've got another function called h. Love h. What's it doing? It's collecting area under the curve of f. The problem is when I go from -1 to 2, so let's go do that. Tell me what the problem is. I don't want to scroll back to the stem of the problem, but tell me what I'm going to need to do. Yeah, go ahead, Cadence. It's not. So I have to stop at the discontinuity, collect the area up till then, and then collect the area of the rest of it. So you're going to need 2. You're going to need to go from -1 to 1. The first piece, I forgot what the first piece was.
X to the third
Thank you.
plus e to the 2x minus 2.
Plus e to the 2. That's the first piece? From -1 to 1? I thought that was the second
Oh,
piece.
that's mine.
Oh.
Gosh.
I was going to say, that wasn't Clocker's original. What was the original?
X squared plus 3x.
X. Way to go, loser. I'm just kidding. The next one, from 1 to 2. So when you can find area when there's a discontinuity as long as there, if you go like that, and then maybe down here, I don't know, you had that, you still have the area of the 2. All right, so this guy, what was it? Go ahead, Caden.
X to the third plus e to the 2x minus 2.
E to the 2x minus 2 dx. These are easy antiderivatives. X cubed over 3, power rule. 3x squared over 2, power rule. From -1 to 1. I don't have a calculator, so we're going to have to discuss how you're going to answer that. X to the 4th over 4, and then I want you to write the second antiderivative because I'm worried about it. What is the antiderivative of e to the 2x minus 2? I'm really worried about what you're going to put in front of e to the 2x minus 2. So once you're done, I want you to take the derivative of your antiderivative in your head. You're nodding. I think you know what I'm afraid you're going to do. Right, Kalia? What's the antiderivative of e to the u? E to the u. And then you might say, oh, and then I multiply by the guts. No, you don't. Because if u is e to the 2x minus 2, right? Du is 2. And we have to do a half of that. How many of you put a half out front? Okay, if you put a 2 out front, and you do what I always tell you to do with your easy antiderivatives, if you took the derivative of this, you would get 2e to the 2x minus 2 times 2, you get 4. So be careful with that. Now I'm going to go use my fundamental theorem. I'm going to put the 1/3 in, or the 1 in, plus 3/2, minus, I'm going to put parentheses down, okay, -1 cubed, plus -1 squared times 3/2, boom, plus, what were my limits, 1 to 2? 2 to the 4th over 4. I would leave it as that because some of you are going to call it 8 because you're going to be going fast. So I'm just going to write 2 to the 4th over 4 plus 1/2 e to the 4 minus squared. We good so far? I'm just plugging the 2 in, minus, parentheses again. And the 1's going to go in, 1/4 plus 1/2 e to the 0. I'm going to actually write that out. 1/2 e to the 0. At this point, Ava, what do you think I should do? It starts with an S, ends with a P, and rhymes with mop. There! Why? Because it's an FRQ, and if you screw up the simplification of that, which is possible because it's fraction nightmare, right? You're going to lose your answer point. So when it goes all numerical, not functions and not variables, but all numerical, you stop for an FRQ. Yes?
You have to leave the e to the 0. Can you just
You can leave it.
Okay.
Or you can make it, if in your head you're like, ah, that's just a 1, so then write 1/4 plus a half. But e to the 0 is a number, so that's why I left it in there. Sine of pi halves is a number. So on an FRQ, you're not 100% sure of your unit circle, leave sine pi halves. But multiple choice is where they're going to make sure you've got your poop in a group on how to simplify. So know how to, but don't on the FRQ. That's my advice for you guys. I hate it. Honestly, too, as a reader, I'm not reading this year. It's my first year in a long time. I said no, but I don't want to. It's from our house, and it was horrible last year not being able to travel and do it, like sitting in my bedroom grading tests the first day off of, it was awful. Anyway, where was I going with that? When one of these comes across my reading table, what do? I go, oh crap, I gotta go make sure the parentheses are in the right spot, and I actually have to check that, and it makes me crabby. And this is the first year I've actually said, just leave it, because I think kids lose little points for it. It's frustrating. All right, number 6 is next. Read it and tell me what I would call this problem. What, when we were doing them, did I call this type of an FRQ? It's a predictable one, and so it goes under a title. It's not graph analysis. It's not particle motion. That last one didn't really go under a title. It's just random questions about a piecewise function. This one is actually usually your number 1. It's calculator active, and usually BC has the same one. What's this called? Rate in, rate out. Okay, so we're just going to set it up because I'm confident you know how to work your calculator for rate in, rate out. So absorb the stem of the problem. What do we have? We have a toll road. It already has 48 cars on it at 9 a.m., which is t equals 0. So you might want to even just put down a fake road and write 48 times 0. That took me 1 second. So just wrap your brain around the stem. And then it says we're entering the toll road at a rate modeled by E of t. I like to put that label on it. What is that in? Hundreds of cars. So 100 cars per hour on the same time interval, boom, leaving the toll road or exiting L of t also in 100 miles. There, that's a good enough picture for me. How about you guys? Your reader's not going to look at your picture, but for part A, how many cars enter? How do I go from hundreds of cars per hour to cars? I integrate my hundreds of cars per hour times hours from 0 to 6. Easy. Where do I go to do that? Math now. Okay, that one's done. Nothing weird about that guy. Next up, I want you to do this one. Just the setups. We're not going to go to our calculator. Write an expression involving 1 or more, which usually means you're going to need 2 or 3, for the total number of cars at any given time. That's going to be the first thing you write down is an expression that if you plugged in 7, it'll give you the amount of cars at time 7. And then they want you to use it at time 3. Okay, so an expression for any time t. And then what will you do? What would you set up for finding the amount of cars on that road at t equals 3? This is not unusual. About 1/4 of the questions you'll be going, that was kind of weird. But about 3/4 of them you should be going, that wasn't weird. This isn't weird. Are you ready? Who haven't I picked on today? I picked on Ava, did Kaden. You up? All right, go ahead, Kalia.
48.
Yes, I was supposed to send you somewhere. Are you coming from where I was supposed to send you?
Yeah.
Okay, great. 48 plus.
The interval from 0 to t,
Mhm.
of dt dt,
Mm-hmm.
minus the interval from 0 to t of L to dt.
Perfect. Or you could have put E of t minus L of t in one integrand, which is what they do in the scoring rubrics, but I like this better. I like it pieced. Yes?
Would it be correct if you say like total or t of x, so like total of x, and
Sure.
then instead of the t's on the top you could do x?
Yes.
Okay.
Yes. They actually, that's how it's going to look on the scoring guidelines, but it says for any time t, so they'll probably have x's in here.
Oh.
But it doesn't really matter because they call them spelling errors because some people's t's look like x's. So they say, yeah, whatever, it's fine. But technically, if we were going to be picky, you should go like that and then plug the t in and it'll go from x to t. But who's to say that's not Bryce's t? You know what I mean? And this isn't Clocker's X. It's too hard to tell. So I would just use all T's for safety. All right, you're not done with it though, because then what do you need to do? Find the total number of cars at t equals 3. So you'd plug a 3 in and go where? Calculator. Last up for number 6, you can predict what they're going to ask, because I said this one's predictable. Usually the next question is about maximizing or minimizing the chicken nuggets or the compost, or last year it was fish in a fishery. They've had people getting on and off an escalator. It's a very, very common FRQ stem, and they're usually very straightforward. So this says find the maximum of cars, and that's where Caden defining the function as the number of cars becomes helpful. You don't have to get the point on the previous one, but because now I need to maximize this function, which was, I'll go back to Kalia's, 0 to t, the amount entering, cars getting on, and then subtracting the cars getting off. All right. What do you think about this one, Bryce? Are you fairly comfortable with, are you guys pretty comfortable with right in, right out? I felt good with it this year. So that's why we're not doing a full day on it. Like we did a full day on graph analysis, but I felt good about this. We did a full day on revolving solids. I felt like this went well, and your test on it went well. So next, to maximize any function, you need to make a candidate table, right? On your table will go the time and the number of cars at that time, and I need to maximize that. So what goes on my table before I even do any work? The endpoints. Maybe more were always getting off than getting on, and I had a maximum at time 0. Maybe more were getting on all the time than were getting off, and my maximum occurred at the end. How do I go figure that out? 0 was given to me in the stem of the problem. Also, when I integrate from 0 to 0, or number to same number of 0, so either way, but how do I figure out 8 at the end of the day? Go ahead. Plug it in on your calculator. So I'm just going to go like this. You're going to go 48 plus math 9, 0 to 8. Let's just do, plug, 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 plug. Now, how do we get our other candidates? Who else could possibly be a maximum if it's not at the beginning or not at the end? Where could it possibly be? Anywhere where the derivative equals 0. The derivative of what? Your function. Which if you don't define it, you'll get stuck. That's why I like your C of t. Some people use A of t for amount, or capital T of t for total, but I would give it a name so you know you're taking its derivative. What's the derivative of 48? 0. What's the derivative of the integral? Undoes it. What's the derivative of the integral? It's like me saying, what's the square of the square root? I need that to equal 0. How do you go figure that out? There's 2 ways. You definitely need a calculator, right? Do you know who knows what I mean when I say there's 2 ways? You guys are so focused, I love it. Yeah, Mel.
Can you just put it in your calculator?
You could just put this in on your calculator, set your window from 0 to 8 for your x's, right? Not really even need to worry about the y's as long as you go from negative to positive. I said I always just set it negative 2 to 2 by 1s if I'm just looking for zeros. And she's going to look at where we cross the x-axis. Or you could
Set E of t equal to L.
You could set E of t equal to L of t, graph one of them in y1, the other in y2, and look for where they do what? Intersect in that interval. The problem with that is, then you do need to be concerned with your y values, because sometimes you can't see the intersections. So like if it goes off your screen, you better enlarge your window so you can make sure they don't cross in that spot you can't see. Did I explain that well enough here? So I prefer Mallory's, just because you're never going to miss where it crosses the x-axis if you can see the entire x-axis. It won't matter what your y's are as long as they hug both sides. Are we good with that one? What do you think about that one? Not too weird, right? All right, you guys are doing awesome. Now we're going to go to the hard one. There's always one. Okay, I'm going to tell you, you're going to come back from that AP exam, And for you guys, I won't see you till the next day, but you're gonna come in and go, oh my God, it was so hard. I couldn't do hardly any of FRQ5. But you're gonna forget that you did all of 1, all of 2, most of 3, and some of 6. Does that make sense? Happens every year. They come in complaining about the weirdo. Here's the weirdo. But the first part of it isn't weird. And you come back only remembering the stuff you were really stuck on because that's what bugged you. The first part of this will get you at least 4 points if you know how to do it. And you do know the first part of this. Are you ready? It says let y be the solution. You should go up here and say, okay, I'm given a differential equation. And y is the solution. And that should trigger the skill. Last one is read in, read out. What skill is this? It's got a name. Separation of variables. And we've done that enough, and we were good at it. So we keep all things y. So I have to divide by 3 minus y to move it over. All things top variable. I shouldn't say y in case they do dw, dp. All things top variable on the left. All things bottom variable and constants on the right. Sometimes it bugs kids when there's nothing left on the right and they're just sitting there with a dt. They'll be like, there's nothing there. There is. It's a 1. And what's the antiderivative of 1? Right? So if it's all gone except the differential, there's a 1 there. All right, what do we do after we separate? We integrate. Which side's easier, left or right? What do you think?
I say right.
I'd say right. Okay. On the right-hand side, what is the antiderivative of cosine? Sine, cosine. This is where I'd be 100% sure, and I would guess sine. Right? So let's do sine x plus c. Awesome. Next up, be very careful. Write down what you think the antiderivative on. By the way, you would already have 2 points. You'd be 1 point below a national average if all you could do was separate and get 1 antiderivative. The other side, be careful. Go through your integration techniques. What does it pass off to? Natural log. Okay. Why? Because if I let u equal, and you shouldn't need to write this on the side, but if you need to, better to get it right, correct? So my du dy, the derivative of this with respect to y is -1. So my du is -1 dy. So I basically have u prime over u if I just do that. So be very, very careful that you don't just say natural log absolute value 3 minus y. Why do I say be very, very careful? There's a fraction correction. If it was y minus 3, then the derivative is 1. If it was 3 minus 8y, what's your fraction correction? -1/8. Yep, so be very careful with that. I'm going to throw a negative here. I could solve for c right now, but I don't want to. Right? But I could. If this looked nice, I would do it, but I'm like 3 minus what? 8? Ooh, ish. Natural log 5? Not feeling it. If it was natural log 1, I go, because what's natural log 1? 0. So I kind of look at it and I go, not feeling it. Let's get that negative out of there. Why did I not make the c negative? It's still a constant. But if Harper had found her c up here to be, let's say, 6, she had to put it in right there, and then it became a -6. So we're just going to let it go. I'm still honestly not feeling it. So how do I undo the natural log? Exponentiate. I know this is taking a while, but these are really good problems today. Wouldn't you agree? These are good. They cover so many skills, so I apologize, but I was going to only do number 4, and then I'm like, I really like 5. And I was like, I love 6. So if you follow my schedule, it went from FRQ4 to FRQ4 and 6 to FRQ4 through 6. I'm like, I can't not do this whole one. They're all really good. All right. Let's see if you remember what to do here. Do we? I think you do. All right, not just Kata. Let's go, Luke. Do you remember what to do here at this juncture?
Don't the
It's okay.
E and the natural log cancel?
They do. So this is just the absolute value, 3 minus y. Do we remember what to do on the right? Look. There's a little move right here that's why I'm going through this whole one. And I was afraid about this guy. So it's taking me long because I'm afraid there's some people who would have forgot little things on parts of this. One was right there, and one is knowing what to do with this side. Can somebody tell me? Go ahead, Harrison. Yeah, this is where we in our head say, well, that's actually e to the sine x times e to the c, because when we multiply, we add exponents. Remember doing that? You don't have to write that down. But like you said, you have to know that e to the c would just become another constant. You can actually let that constant absorb the absolute value. Okay? So it'll be c e to the negative sine x. Honestly, I'm still not feeling it. If you don't mind, I'm going to wait till I'm done to find Carl because I'm just on a roll. So I'm going to add the y over. So I get y equals what? Y equals 3 minus, then what? C e to the negative sine x. I think I'll find c now. Just because I was on a roll, you guys. I was having fun. All right. So what do I put in for y? Be careful. What's the y value of the initial condition? 8. Has to equal 3 minus c e to the 0, right? Because sine 0 is 0. What's c? Be careful. You don't want to screw up here. What's c? Negative 5. And when you put it in for c, be careful. It'll be 3 plus. So 3 plus 5. And I don't like negative exponents, but you could leave it. But I'm going to throw it in the denominator because I know the question for part B already. So let's go look at that. Now that took a long time, but this is like a 1 second deal. As I send x to pi halves, when I take a limit, I plug it in. This would be worth just 1 point. What is sine of pi over 2? Unit circle. 1. This is really just 3 plus 5 over e. That's what the limit would be. So when I send x to pi halves, I plug it in. I'm just going to write of y. I would get 3 plus 5 over e to the sine pi over 2. Can you leave it like that? Yes. And if you don't know your unit circle, then I'm not sure if it's 0 or 1. You better know it's 1 and make me cry big alligator tears, but I would never know because I'll never see your test. All right. So next up is a doozy. But weren't those 2 parts okay? But what you guys are going to come back and do is you're going to say, oh my God, that number 5, I quit because you won't be able to do this one. But you're already 3 points over the national average with the first 2 parts. So keep that in the back of your head because when we get discouraged, we stop thinking as hard. Most kids across the world won't get this one. It's going to happen on several. All right, letter C. I want you to read it. And I know this is taking a long time, but it's such good learning today. Aren't you learning stuff? Harper's nodding. I hope you are. If you're not learning anything today, that's actually great, but it would make me sad for wasting your money. I'm in a good mood today. I don't know why. I think it's because I got my tooth fixed. I got in emergency to the not emergency, but they had a cancellation. I wasn't supposed to get into the dentist till next week, and I chipped a filling between 2 teeth. And so food was always getting stuck, and then my gums were getting sore, and I was flossing all the time, and I had a constant toothache. And they called me yesterday and said I could come in at 2:15, so I left 6 hours early. I went in, they drilled it all out, and I hate that. I'm an anti-dentite. Like, I hate the dentist. Sorry, we're supposed to be doing this problem, but I just want to tell you. So I went in super nervous, and I did chemotherapy without a port. Like, I was a champ. I had a bunch of surgery. I was a champ, but the dentist gives me, like, I swear my blood pressure was through the roof. I'm laying there going, is this going to hurt? I'm like, what is wrong with me? But are any of you like that with the dentist? Like, honestly, they come at you with that. And I said, I hate it. And they said, should we call it Mr. Whistler like we do with our 4-year-olds? And I'm like, Anyway, so they go in, they drill it out. Well, first of all, they have to put the needle in my gum. I'm like, oh. And for chemo, at least it's in my arm. If they couldn't get it there, it's in my foot. But in my mouth, in my gum, above my tooth, I was like, oh. So they did that, and they drilled it out, and then they packed it back in, and then they had to use that drill. And I said, I don't like the word drill. He said, I'll call it a fast rotary device. And, and so anyway, they do that, and I left, and I'm like, oh my God, I didn't realize how much pain I'd been in. Aren't I in a good mood? Was I crabby this last 2 weeks? I've had a toothache, like, and it's irradiated into my ear. Have you ever had one? Like, oh. And I didn't get pain medication for it because I'm allergic to it. So I was like popping Advil, and I had stomachache. All right, enough about me. What do you guys think about me? Just kidding. All right, letter C. Sorry, distance learners. I forgot I'm recording. You're probably at home going, oh my God. Hopefully you fast forwarded all of that. I forgot I was recording them. Oh my gosh. And it's going to be on YouTube. I'm going to actually set that to unlisted. All right. What am I doing here? All right, letter C. I'm getting goofy. Letter C. Y equal g of x is a particular solution to the given differential equation, which means it has the derivative of dy dx that was in the stem of the problem that I forgot. But we're going to write that down. dy dx or dg dx, because y is a solution and y is g of x. Can you tell me what dy dx was? Because I know it had a 3 minus y cosine x. Perfect. All right. So that's the first part. It's just knowing what it means to be a solution. It means its derivative is what the derivative says it is. All right. So it says with initial condition, g of pi over 2. I'm going to be needing to plug that into something. I don't know what yet. Equals 4. Sorry. I'm just going to put pi over 2 comma 4. Find the value of the second derivative. Okay. Well, I need to go take the second derivative. With respect to what variable? X. So I need to do the derivative with respect to x of the left-hand side. That's why it gets that notation, by the way. If you've ever wondered why it goes d squared y, dx squared, look at, have you ever wondered that? Or did I explain that already this year? I might have. I did. Some years I don't. And I get, you guys think, oh, I'm like, I must have told them already. All right. On this side, I need to do the derivative with respect to x. You might say, why are you writing it like that? Because this is implicit differentiation in a second derivative in a diffie-q. So you have to be very careful. And you're going to go to this side. And remember, you have all the tools to do everything. This is the what rule? Product rule with little funk to it. Have you done one like this? Never. Should you know how to do one? Probably not, but do you have the tools in there? 100%. We do first, d second with respect to x, and the derivative of cosine is 100% sure, because it's the signs are going to, the positives and negatives of this are going to make all the difference. All right, so what's the derivative of cosine? Negative sine x. I love that, you guys. I know this is long. It's just so good. So first d second plus second. Be very, very careful. And you might even want to write. I'm going to just write that out. So, there. Whoops. 3 minus 1. 3 minus y. That didn't feel right either. All right, I can't get it. I do. I got it. Why do you think I said I would just write it out? What does that require? Right, oh, distance learners can't see me pointing. What does that require? What's the derivative of this? Negative 1. If I did dy dy. Right? But if I do dy dy, I better multiply by dy dx. Right? I mean, so be very careful. All right, so let's go back here. I have a negative. I have a 3 minus y. I have a sine x. Be very, 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 very careful. What am I going to write? What is the derivative with respect to x of 3 minus y? Well, I've got the cosine x. I can write that down. I want to see if you would know that. Do you know, Kaden, what is it?
Negative dy dx.
Negative dy dx. It's negative y prime, but I wouldn't use that prime notation unless your brain is really good at knowing that it's actually dy. Excellent. It's the derivative with respect to y times dy dx. And dy dx, I'm just going to write it like that. I lost track of what we were supposed to find because in my first class. Can you tell me in the STEM? It said I had to find the second derivative, but it had something. At this point?
Yeah.
Oh, perfect. All right, so now I'm putting in a pi over 2 for what? X, and a 4 for y. So I'll have a negative 1, 3 minus 4, sine pi over 2. What's sine of pi over 2? 1. All right. Then cosine pi over 2 is 0. So I'm not even going to bother going on with the rest of it. Do you see what? This is hard, but do we have all the skills for this, Peyton? There's nothing new that I've said in here. It's just a lot of stuff in one problem. My second derivative is 1. Perfect. There was more to the stem, and I saw a sentence that I didn't read. Luke, can you tell me what the rest of it said?
Does g of x have relative minimum, maximum, or either?
Oh, so I need to know if this has a relative min, max, or neither. To be a relative min or max, you have to have a critical value. The derivative has to equal what? 0. So let's verify that our derivative equals 0. My dy dx at pi over 2 comma 4 was equal to 3 minus y times cosine, thank you, of the x. What's cosine pi over 2? 0. So I do have a critical value. If that was anything other than 0, what would I write? I would write neither, right? We have to have a derivative equal to 0. Here's what I think most kids across the world, and most of you, are going to struggle to decide whether it's a min or a max because you can't make a sign line. But you know the second derivative. And what does the second derivative tell you about a function? Concave up or concave down? So if our second derivative was positive 1, we're concave up at a critical value. We've done that, but never have we seen it in this context. So are we at a relative min or max? Now suppose, Sam, you could think all that through and you write therefore min. You won't get that point because that's a 50-50 guess. So you have to, be careful with that. So you're going to say, since the second derivative, and you can call it y double prime or whatever you want to call it, is greater than 0 at a critical value, which was, you can even write critical point or critical value, it doesn't really matter. That's why, right? You're concave up at a critical value. A lot of people think max because they see this greater than. So a lot of kids write max when they get a second derivative that's positive. They're like, oh, it's big. Well, no, it just means the function curves up. So we're concave up at a critical value. So therefore, there's a min there. Wow, we're done. That was long. Sorry, distance learners. All right, so what is our assignment for today? You are to look through a journey from A to Z. If you're OCD, I feel sorry for you because you're going to want to do the entire journey. It's going to take a really long time. So if you want to, but I mean, you might, if that's you, that's you. But I hope that you go A, yep, B, yep. I hope you go like this. C, yep, D, I'm going to do that one. E, yep, F, I have no clue. Put a question mark there. Okay? And go fix when you're done. The ones you did, correct them. The question marks do in a different color. Does that make sense? And if it's the whole thing, I am sorry.